Hello everyone, welcome to Illustrative Learning. In this video we're going to reinforce our knowledge in natural strain by solving the problem. In this problem, we are required to determine the change in length of the shocks caused by the loads. First step to solve this problem is we need to compute the internal forces for its segment. That means we need to compute the internal force in segment AB, for segment BC, and segment C. And there is a method that we're going to use so that we can expose the internal forces in segments through the use of the method of sections. We will start with segment AB. So we pass the cutting plane between segment AB, and then we consider either the left or the right section and to determine the free body diagram. In this case, I considered the left portion. So we have to include the external forces at MA, that is 9 kilonewton. And then to make this in equilibrium, we need to apply the force that is opposite the direction of the line going, and that is our internal force in AB. So using equilibrium, we have 0 equals to AB minus 9, so we can easily determine PAB to be equals to 9 kilonewton. And since the direction of our internal force is away from the body, that means we have tension. Next, we consider segment BC. Again, we will pass a cutting plane between BC. And then extract the free-body diagram by considering either the left or the right portion of the figure. Again, in this case, I consider the left portion. Okay, so we have here the internal force of your BC. And applying equilibrium, we have summation of forces along the x direction is equivalent to 0. So that gives us PBC is equivalent to 9 kilonewton. And again, since the arrow is directed away from the body, we have also tension. Then we compute the internal force at segment CD by still using the method of section. Pass the cutting plane at segment CD and then isolate the left or the right portion for its free body diagram. And in this case, I considered the right portion. Applying the equations of equilibrium will give us PCD is equivalent to 18 kilonewton. And since the arrow is directed toward the body, we have a compressive force on segment CD. The next step is to determine the change in length for its segment. That means we need to compute the change in length for segment AB, segment BC, and segment CD. The formula is the change in length delta is equivalent to your P, the force, the length L, the cross-sectional area A, and the modulus of elasticity E. And then, if we're going to use this formula, we need to be consistent of the unit. For the deformation, we have millimeters. For P, we have Newton. For L, we have millimeters, area, square millimeters, and for your E, we have Newton per square millimeters. Let's start with segment AB. Using the formula, the change in length in AB is equivalent to the load at AB times the length of AB divided by the cross-sectional of AB and the modulus of elasticity. And we know that the load AB is equivalent to 9 kilonewton. To make it Newton, we have to multiply that by 1000, so we have 9,000 Newton. For the length, we have 1,500 millimeters. And for the area, that's a circle, so we have 5/4 d squared, and multiplied by 200 megapascal. So that will give us the change in length for AB to be 0.597 millimeters. And since it's tension, we will have elongation. Next, we compute the change in length at segment BC. Using the same formula, so PBC is equivalent also to 9,000 Newton, but the length now is only 1,200 millimeters. And we have a larger diameter of 20 mm. So that will give us a bigger area, but we have the same modulus of elasticity. So the change in the length at segment BC is equivalent to 0.172 millimeters. And since PBC is in tension, we also have elongation for this segment. Next, we compute force, the change in length for segment CD. Using again the same formula, where your deformation is equivalent to the product of load and the length divided by the area at the modulus of elasticity. We have 18,000 Newton for the load at segment CD, 1,200 millimeters for its length. We have the same diameter, 20 mm, and the same modulus of elasticity of 200 megapascal. That will give us change in length equivalent to 0.344 millimeters. And since our PCB is in compression, that will give us contraction. And finally, we can now compute the total length, the total change in length of the shaft by combining all the changes in length per segment. We have to use positive for elongation and negative for contraction to distinguish the two types of deformation. So now the total change in the length of the shaft is equivalent to the change in length for segment AB plus the change in length for segment BC and the change in length for segment CD. And now 0.597 plus 0.172 minus 0.344, that will give us a total change in length of 0.425 millimeters. And since the answer is positive, we have an equation. So the bar or the shaft will increase by 0.425 millimeters. Thank you.